Hi students, welcome back. In this class we will talk about velocity in spherical mirrors. Now you can see the screen right now, and I have tried to explain. First and foremost, let's quickly review two important formulas or things which we would be using very frequently. One being the plane mirror. In the plane mirror, if the object is going towards the mirror in the direction of mirror with the speed of VO, as you can see here, the mirror is moving in the same direction with the velocity Vm. Then image will move, of course, in this direction, because the nearer it goes, the the nearer the image comes, especially when it is a plane mirror. In that case, we can say Vm is equal to V naught plus Vi, which is image, velocity of the image, divided by 2. Again, let me quickly repeat it. So if object moves perpendicular to mirror, as shown in this diagram, this is a plane mirror, and the plane mirror is moving with the speed of Vm, and object is moving towards the mirror with the speed of Vo. So in that case, the image will come in this direction. So there would be some velocity of the image in this direction. Now, to tie the relation between Vm, Vo and Vi, we can say Vm is equal to V naught plus Vi by 2. Right? Just keep that in mind because we would be using it very frequently. Okay. Now in the second case, if the object moves perpendicular to mirror as shown here, now in that case we know that the velocity of object and velocity of image would be the same. Now remember one important thing, that velocity is a vector quantity. So here it is Vo vector is equal to V image vector. Similarly, here we are talking about velocities. In the first case, which we already discussed, we are talking about the velocity of mirror, object and image. Remember, it is not speed. When we talk about velocities, we have to consider the direction as well. So this relation is the vector relation we have. Just keep it in your mind because we would be using it very frequently going forward. Let me move ahead. We will study 4 cases here. In this lecture we will study 4 cases. First case is when object, we have the mirror here. Remember, it is not the plane mirror, it can be any mirror. I have tried to draw the concave, but again it can be any mirror. So velocity, when we are moving with the velocity on the principal axis towards the mirror. In the second case, when we are moving perpendicular to the principal axis. What is the principal axis? This is the principal axis. So perpendicular to the principal axis with some velocity, let's say O. In the third case, when we are moving with the velocity of theta with the principal axis towards the mirror or towards the lens, whatever it is. Okay. And then the fourth case which we will be studying is when we are traveling towards the mirror or lens with some velocity parallel to the principal axis. Remember, it is not in the principal axis, it is parallel to the principal axis. So we will study these 4 cases. Let's quickly cover one by one each of these. Let me move ahead. Now before moving ahead, let me quickly introduce you with something very important which we would be needing, okay. Now in this case, we know that 1 by f, let's say this is a concave mirror and we are trying to derive the velocities and tie up the relation between the velocity of mirror and image. Now we know 1 by f is equal to 1 by u plus 1 by v. Okay, 1 by f is equal to 1 by u plus 1 by v, or we can write it in this way: f to the power of minus 1 is equal to u to the power minus 1 plus v to the power minus 1. Now we are differentiating with respect to time. If we differentiate it with respect to time, remember focal length is a constant. So if we differentiate it, it will become 0. So this becomes 0. If I differentiate this becomes, basically I have written it here. This becomes u to the power minus 2 minus 1. This is a simple differentiation, and du by dt. Similarly, when we differentiate this, we get this, which is v to the power minus 2 dv by dt into minus 1. Further, if I get this side, I can say 1 by v square dv dt is equal to 1 by u square du dt. Or I can say, dv by dt, if I get this v square here, we just cross multiply here. So this becomes dv by dt is equal to minus v square by u square du by dt. What is dv by dt? dv by dt is the velocity of image. Remember, it is with respect to the mirror, pole of the mirror. So I have written m. So I am writing vector Vim is equal to minus v square by u square, and what is du by dt is nothing but velocity of object with respect to the pole of the mirror, because as I always said, all the movements, velocities, everything is with respect to the pole. Okay, till here I think we are clear. Now I am getting it, I can say this can be written as per the simple law of vector. I can say this is nothing but vi minus vm, or minus v square by u square is equal to this vo minus vm. Remember, it is along x-axis, principal axis. So this is the final derivation we have, which we would be using, which relates the velocity of image, velocity of mirror, velocity of object, together, and this is along x-axis or as the principal axis. Let's do some question related to it. Now the question which you see on the screen, this says that they have given focal length as 20 centimeter. Remember, it's a concave mirror, so focal length would be negative. Now u is equal to minus 40 centimeter, right, which they have given. We know, if we find, we have been given f, which is focal length. We have been given distance of image, pole and object as 40 centimeter. So remember, the incident ray here in this case would be in this direction, facing the mirror. So the direction of u is always from pole to the object, which is in opposite directions. Pole to object is this direction, which is opposite to incident ray. So hence u is equal to minus 40 centimeter. V is equal to uf, u minus f. I just apply the formula using the signs here, which you see. I get v is equal to minus 40 centimeters. Simple mathematics. Now they are asking us find the velocity of the image. They have given us this 2 centimeter. The velocity of object is, they have given us 2 centimeter per second. we will quickly put the formula which we have derived earlier in our last slide, and we will put it, we will try to apply things here. So if I apply the formula here, I can say dv by dt is equal to minus v square by u square du by dt, correct? Now further I can say vi minus vm is equal to minus v square by u square vo minus vm. This we derived. So I just put the formula. See, velocity of object is 2, and I have considered, because the incident ray is in this direction, so this is positive. Okay, so 2 centimeter per second is positive. Velocity of mirror, in this case they have said this is not moving, so this is 0. Put v square by u square, use this formula. Velocity of mirror is 0, so I get vi is equal to 2 minus 2 centimeter per second. Okay, so this is the velocity of the image, minus 2 centimeter per second, using the formula which we have derived in the earlier slide. The formula which we have used is, again, I'm just reiterating because we'll be using it extensively. dv by dt is equal to minus v square by u square du by dt. Vim is equal to minus with this om with respect to mirror along x-axis, principal axis, and that is what we have used here. Okay, let's do one more question. Now this is a question wherein we have been given, this is a, remember, this is a convex mirror, and the moment we say convex mirror, focal length is always plus 20. I'm sorry, plus 20 is because they have given in this question. So focal length is equal to plus 20, u is equal to minus 20 centimeter. You know why? Remember, here the focal length, the direction, the positive direction is in this direction. Which direction? It's going this way, so this would be positive. And why focal length is plus 20? Because the moment I complete this as a sphere, focal length would lie somewhere between, and focal length, as I said, is always, or u or v, is from pole to that position. So pole to focus, so it will be in this direction. And in convex lens, incident ray would be hitting here like this. Okay, so focal length is plus 20 centimeter. Okay, u is equal to minus 20 centimeter. Okay, u is equal to minus 20 centimeter because object is here and the distance from pole to object is, the vector comes this way. Okay, now just quickly applying the formula which we know, v is equal to uf, u minus f, we get v is equal to 10 centimeter. Now we have to find the velocity of the image. Now the first case here, what they have done is, they have given the velocity of this, they have given the velocity of the mirror as 4 centimeter per second in this direction. Quickly applying this formula which we have derived earlier, vi minus 4 is equal to minus 10 square minus 20 square minus 6 minus 4, and we got velocity of image is equal to 6.5 centimeter per second. Okay, pause your screen and go through it. If you need reiteration, rewind and go through the video again. Let me quickly go to the next. Now we will talk about when the object moves perpendicular to the principal axis. So if the object moves perpendicular to the principal axis, let's say the speed given here is 2 centimeter, per second. This is the distance 30 centimeter. F is equal to 20 centimeter. Now this is the concave mirror, remember. So in concave mirror, focal length is always minus 20. Now V is equal to UF, U minus F. We can we can find, we know U is constant and V is also constant. Correct? Now one important thing here, which differs from previously what we have done in the last slide, is that here magnification also comes into play. Now we know magnification is HI by HO is equal to minus V by U. Correct? Or I can write it HI by HO is equal to minus V by U, or I can say HI is equal to minus V by U HO. Okay. Now if I differentiate both sides with respect to time, I'll get dHI by dt is equal to minus V by U dHO by dt. Further, quickly moving here, I have written the same thing here, and then dHI by dt is nothing but velocity of image, but in this vertical direction right now, is equal to minus V by U. VO is also in this direction. So both this and this are in y-axis. Remember, this is y-axis and this is x-axis. So this is a new thing which has come up now. Earlier we were talking about only along the principal axis, but now perpendicular to the principal axis also comes into play, and then the speed is y-axis, both sides. Vi is along y-axis and Vo is y-axis. Just take a note. We will quickly move to a question. Now another question, or I can say, when an object moves perpendicular to principal axis, dHI by dt is equal to this, or I can say this, and both are across y-axis. This is what we studied and I have reiterated it here. Now if I get a question wherein they have given this direction, this speed, remember magnification we were talking towards up, but in this case they have given minus downwards because it is downwards. So and they have given focal length as 20 centimeter. It's a concave mirror, so focal length would be minus 20. U is equal to minus 30 they have given. Now we can easily find V. V is equal to this UF divided by U minus F. So I can just find minus 30 into minus 20, minus 30 plus 20, I get V is equal to minus 60. Now I have to find this movement downwards is in force with the speed of 4 centimeter per second. We have to find with what velocity the image will move. Very simple. We will quickly apply this formula. So if I just Vi is equal to minus 60 by minus 30 into 2 centimeter per second. What is 2? 2 is the speed they have given. So guys, my bad, I think I misconstrued this question that the speed is this in this direction. No. Let me reiterate the question again. In the question what they have done is they have given you focal length, they have given you speed of the movement of object in this direction. So the speed of moving this object is 2 centimeter per second, not this. This is the final result. So please ignore it right now. They have given you, focal length. They have given you U as 30 centimeters. So the distance is always from, in this case, because it's a concave mirror, incident ray would be this, from here to here. So it will be minus 30, U is minus 30, F is minus 20. I will get V is equal to minus 60 centimeter. Now I have to find the speed if the object, I have to find the speed of image if the object is moving 2 centimeter per second. So if the object is moving 2 centimeter per second, quickly apply this formula, the one which we have studied. Remember, this is also y-axis and this is also y-axis. So if I put it this, I get Vi is equal to minus 4 centimeter per second, which is in, because it is minus, so the speed of image is downwards, is moving downwards with the speed of minus 4 centimeter per second, where at the point V is equal to minus 60. So this, the distance from here to here is minus 60, and image is moving in this direction at a speed of 4 centimeter per second, and that's why it's minus 4, because it is downwards. Okay, pause the screen, go through it. You'll get ample of questions in couple of books wherein, and I will give you an extra resources as well wherein you can revise. Okay, so with this I'm taking a pause here. We will continue with something very interesting in the next lecture. Thank you very much.